everyone, welcome again to another video of Making Math Easy for Better Understanding. Still, this is your teacher Hazel, and for today's video, we will discuss about partial fraction decomposition and repeating quadratic factors.
First, let us discuss what is a quadratic equation. An algebraic expression of the second degree x, its standard form is ax squared plus bx plus c equals 0, wherein a, b, and c are the coefficients, x is the variable, and c is the constant. When we say repeating quadratic factors, if an irreducible quadratic factor ax squared plus bx plus c occurs p times as a factor of the denominator of the given fraction, then corresponding to this factor associate the p partial fractions, meaning the denominator of a certain fraction would repeat p times. So it could repeat twice, thrice, or many others. So it could be in the form ax plus b over ax squared plus bx plus c plus ax plus b over the quantity of ax squared plus bx plus c squared up to infinity. So this is where a and b are constant and not both 0. So we have here our example, which is x squared minus 4x plus 1 all over the quantity of x squared plus 1 squared. So its partial fraction would be ax plus b all over x squared plus 1 plus cx plus d all over the quantity of x squared plus 1 squared. Now let us solve for our equation x squared minus 4x plus 1 all over the quantity of x squared plus 1 squared. So since the denominator is repeating, it would repeat twice as a factor of the fraction. So we will equate this to its partial fraction of ax plus b all over x squared plus 1 plus cx plus d all over x squared plus 1 squared. So as you can see, we would just, since it is a repeating quadratic function, we would just increase the exponent of the denominator one at a time. So in the first factor, we have 1 as the exponent, and then in the second factor, we have 2 as its exponent in the denominator. So let us find the LCD of their LCD to solve for the values of a, b, c, and d. So their LCD would be x squared plus 1 squared. So we will multiply this LCD to the numerator and then divide it to the denominator. So we have now x squared plus minus 4x plus 1, that would be minus times x squared plus 1 squared all over x squared plus 1, or the quantity of x squared plus 1 squared, and then multiply the numerator of the first factor to the LCD, then divide it to its denominator. So we have ax plus b times x squared plus 1 squared all over x squared plus 1 plus the second factor numerator, the numerator of the second factor multiplied to the LCD, then divided by its denominator. And then let us now cancel common terms in the numerators and the denominators. So that left us with x squared plus 4 minus 4x plus 1 minus 4x plus 1 equals the quantity of ax plus b times the quantity of x squared plus 1. Plus the quantity of cx plus d, or cx plus d. And then let us expand ax plus b times x squared plus 1 using a long method, or long method of multiplication of polynomials. So that would be ax cubed plus ax plus bx squared plus b plus just copy the cx plus d. And then let us combine like terms. Just copy the equation on the left side of the equation. So that would let us just copy x squared minus 4x plus 1 and then combine like terms on the right side of the equation. So that gives us ax cubed plus bx squared plus ax plus cx plus d plus b plus d. And then let us factor out ax cubed plus the right side of the equation. So let us factor out ax plus cx. So that would be x times the quantity of a plus c plus the quantity of b plus d. So now, as you can see on our left side of the equation, we have a quadratic equation. However, on the right side, we have a cubic equation. So that means that the coefficient of the cubic term on the right side would be equated or would equate to 0. So that makes a equals 0. And then the second term, which is a quadratic, would be equated also to the coefficient on the left side. So b equals 1. And then the coefficient of the linear term, a plus c would be equated to -4, and then the constant b plus d would be equate to 1. So now we have our values for a and b. So we could use the value of a, substitute it in the third variable to find the value of c. So 0 plus c would be c, so that gives us c equals -4. And then the value of b will be substituted in the fourth equation to find the value of d. So 1 plus d equals 1. Using additive inverse property, move 1 to the right side of the equation. That would be d equals 1 minus 1. So we have now d equals 0. So we already have our values for a, b, c, and d. So we could now solve, or we could now get our partial fraction for this repeated quadratic equation, x squared minus 4x plus 1 all over x squared, or the quantity of x squared plus 1 squared. So just substitute the values for a, b, c, and d. So we have now 0x plus 1 all over x squared plus 1 plus -4x plus 0 over x squared plus 1 squared. So we could write this on its lowest term as 1 over x squared plus 1 minus 4x all over the quantity of x squared plus 1 squared. So that's now your answer.
And that's the end of our video. I hope that you've enjoyed the video and you've learned something. And don't forget to like, comment, share, and hit the notification bell for more updates.